we start from where we left in last class. So last class we left with a portion where we said, based on the two experiments, we studied about potassium permanganate as one experiment. Okay, we also saw the experiment of sugar dissolving. Then we saw bromine vapor mixing. We came with 4 conclusions. So what were the 4 conclusions? And we're going to discuss about those 4 conclusions to take our story forward from here. Okay, the 4 conclusions that we had, the first conclusion was the particles of matter. Okay, the particles of matter, okay, the particles of matter are very small. And how did you get to know about it? The particles of matter from the potassium permanganate experiment, right? You took a crystal and you dumped that crystal into a beaker of fresh water, and then what happened? The entire beaker started to get pink in color. That means, and you could not distinguish any particle out there. So the particle, there must be some particles which were in motion, and they went and then mixed across. Okay, the particles of matter are very small. The second one was the particles of matter are in motion. They are in motion. This was the Brownian motion that we discussed. Pollen grains hit by water particles. Then the third one, we said that the particles of matter have space between them. Particles of matter, what was it? Have space between them. How did you understand have space between them? Sugar dissolved in water. और चौथा क्या था? Particles of matter attract each other. Matter attract each other. We'll have a little bit of more discussion on each of these points and then build our knowledge from here to go forward. Okay. Hey Harshit, okay, fine. Particles of matter are very small. Both some are sitting together. So let's understand this. Particles of matter are very small. हमें इसका एक सबूत चाहिए. What is the proof for this, that the particles of matter are extremely small? Now for this also we can have one more type of an experiment. What is the type of an experiment that we'll do? So what we do, we had mixed potassium permanganate crystal in fresh water, if you remember, right? So what we have taken now, we have taken, say, 3 or 4 beakers we have taken, right? Right. And on the first beaker, what are we keeping is the same beaker where we had the pink colored solution. Pink colored solution. Correct. And on every other beaker we'll be having fresh water, which is colorless. Colorless hai. This is also colorless. This is also colorless and colorless. So आइए इसका एक्सपेरिमेंट देखते हैं. So what we do, ये पता है कौन सा है? ये उस दिन वाला बीकर है. What was it? This was a beaker of fresh water in which we had put a lump of potassium permanganate. The entire potassium permanganate mixed through it and it became pink in color. Now what we do, we take a small sample from here. And we take a small sample, say a drop from here, and you put that drop of pink into the second beaker. Okay, let's number the beakers also. So this was the original sample. So this is, say, sample 1, sample 2, and sample 3. And you drop one drop from this concentrated pink color into the second beaker. You will see that after some time, this particular beaker has also turned pink in color, but there will be one small change. What is that? It will be a little bit pale or lighter. ये तो समझ में आ रहा है ना? ये concentrated है, उससे यहाँ पे लिया. So it will become, this is going to turn pink, but the pink would not be as dark or as concentrated that you saw here. After that, what we do, we take another drop from here and we drop it here. Again, this will become pink, but will be more dilute. यहाँ से एक चीज समझ में आ रहा है. You are taking one drop. So what are you taking from each beaker? You are taking a drop which is nothing but matter, right? This is also matter. This matter has gone into my first sample and has spread evenly across. So how does it spread evenly across? There must be particles which we have already studied, and these particles are very small. Can you see anything which is actually moving from here to there. With the naked eyes, you can't see. But the mixing is very, very uniform. This shows that the particles of matter are extremely small. What is happening? Yes, definitely we will get a lighter tone on each sample. The lighter tone still shows that no matter that, if you still take an even lighter sample from here to here, if you take another lighter sample, even this will also become pink, which shows that matter is composed of very small particles, and these small particles are going and occupying what? Spaces. What spaces? They are taking the spaces between the water molecule. थोड़ा सा ये कहानी को भी देख लेते हैं. So if you see, there is a contest between two type of particles. This is a water particle, and then we have a potassium permanganate particle, right? So this is potassium permanganate, KMnO4 as we call it. You should start writing all these. KMnO4, and this is my water particle. So water particles have spaces between them, and those spaces are getting occupied by what? Potassium permanganate, and in a very even process. और even कैसे समझ में आता है? ये इतना टूट जाता है, it breaks and breaks into so small particles you can't see, but what you see is a very nice outcome, that the entire solution sample has become uniform in texture, just that the texture becomes lighter and lighter. This experiment proves to us that particles of matter are very small. Anyone has any doubt out here? Okay. But whenever you have a doubt, you can just stop the class and ask. Okay, I would only request you, since you have joined first time today, do not hesitate thinking that, if I ask, somebody might think I don't know. There's nothing like that. You can just stop and you can just ask that I have not understood this part. I have no issues. But don't progress without understanding, so that next when I ask you or I ask anyone, at that time you get stuck up and you say, no, I don't understand this. So please it's your class, be as informal. And will I get angry? I don't get angry, I say that. But sometimes, yes, I'm also a human being. If somebody hides something from me, they are straight away laughing, thinking that I don't get angry. Bolo.
Small amount, it becomes tiny.
Yeah, the liquid should get clear at some time. The liquid, at the end of the day, what are you taking? You are taking matter. How do you know that this matter is only potassium permanganate? There was water. So this matter is actually having both type of particles. But in the first beaker, when we are taking, we expect more. If you take, say, 1 ml sample, 1 ml will have more of pinks, less of whites. Next time, the pinks still are more, but the whites have increased their quantity. Next, the whites are increasing their quantity. And so and so and so. Sometimes you will find now that what is remaining is only the whites are in majority. And then one fine day, you should get clear water only. This is not that only KMnO4 is coming out, okay? Please understand, this is matter coming out. And in this sample, there will be KMnO4 also. How can you, with one dropper or one syringe, only pull out KMnO4? You're not God. What you're pulling out is a mixture. In that mixture, KMnO4 is more, water is less. That's the reason you are able to transfer it. And every time you are transferring, the KMnO4 content is reducing. As KMnO4's content reduces, the color starts becoming pale, and sometime later, maybe after some 70-80 iterations, we should get only clear water. Clear? Okay. Let's target number 3 first and then go to number 2. Particles of matter have space between them. Now, this can be understood again by mixing sugar in water. We'll mix sugar in water. I hope you know H2O. I'm writing H2O. H2O stands for water. We call it water, but the chemical name should be dihydrogen oxide. Okay. Mixing sugar in water, but we'll be a little bit more specific. Let's say you take a measured quantity, something around, say, 50 grams of sugar, and you take 100 ml of water. 100 ml is very common measurement. 100 ml. 100 ml of water and 50 grams of sugar. सुनिए क्या होता है इसमें? What are we trying to prove? Matter, particles of matter have space in between them. Did you understand? Space in between them. If a school bus comes with very less number of children, then do we say there are seats in the bus? Yes. If there are seats in the bus, after new children get in, There should not be discomfort to anyone. There should not be any frowning faces. Everyone should be as happy as they are, as long as you see that your likable faces have boarded the bus, right? So, what we are doing when we mix 50 grams of sugar in 100 ml of water, after mixing, so we use the word post mixing. Post mixing, you will still see that the volume still remains 100 ml. ये समझ में आया? 100 ml means एक glass में आपने 100 ml water लिया, and in that 100 ml water you are mixing 50 grams sugar. If you actually give a non-dissolvable solid, जैसे पानी में आप एक पोटैटो फेंक दोगे तो पानी ऊपर आ जाएगा ना, यहाँ पे नहीं आया. The volume of water did not increase, and the sugar also went inside. Where did the sugar go? The sugar particles went and occupied the spaces between the water particles. यहाँ आगे जाने के लिए कुछ और चीजें भी यहीं से सीख के जाते हैं. Sugar was what? Solid. Water is liquid. We get an understanding. We never said water went between sugar. Sugar went between water. यहाँ से एक चीज समझने में आता है. Liquid particles are more far apart as compared to solid particles. The liquids allowed the solid to get in between. The solid कभी भी liquid को घुसने नहीं देगा. Unless and until you have something like sponge. Sponge घुसने देता है, उसमें pores रहते हैं, वो अलग बात है. ठीक है? So the liquid particles, now we are studying about space between them. We are not debating who has more space or who has less space. But if we try to see the future story, our discussion has to go in that line. Sugar पानी के अंदर चला गया, and पानी is what? Liquid. Liquid have more space than solid particles. Therefore, liquid is saying, solid, solid, आ जाओ, बैठ जाओ मेरे साइड में. Solid कभी नहीं बोलेगा, liquid आ जाओ, बैठ जाओ. कभी नहीं. Take your pen, dip it in water, the entire water just runs down the body of the pen. The water could not get inside. Why? Because the solid particles did not allow the water molecules to go and get sit inside. Right? Is this clear? So can I take this one also? हाँ जरूर. हाँ वेट बढ़ सकता है. वेट तो बढ़ेगा ही 100%. वॉल्यूम नहीं बढ़ रहा है. वेट और वॉल्यूम दो अलग अलग चीज है. वेट बढ़ सकता है, वॉल्यूम नहीं बढ़ेगा. Understood? 1 liter of mustard oil that you buy and 1 liter of petrol, if put in a 1 liter can, will occupy a complete space, but their weights can be different. Obviously. Yes or no? Then we go on to particles of matter are in motion. How did we describe this? This was described through diffusion. अब diffusion के ऊपर थोड़ा सा detailed discussion करेंगे. Diffusion. What is diffusion? Diffusion is the movement of particles from region of high concentration to region of low concentration. So we will have particles. Particles. And particles will move always from high concentration to low concentration. One of the best example was that I cook biryani in my house and you get inside my house. So the aura or the flavor or the aroma of biryani spreads. My house is now concentrated region because the biryani has been cooked in my house. So my house is highly concentrated with biryani aura. And when you enter, your nostrils are in low concentration. So you immediately come in and say, sir, you cooked biryani today. So you can actually smell it. But after staying for some time, you also get into the same amount of concentration. So you don't, after 10-20 minutes, you don't ask that question. But if somebody new again comes, he or she will again say, कुछ नया अच्छा बनाया है आपने. Fragrance, perfume, odor, and say your what you call agarbatti or the incense sticks that we burn. They all, there's aroma spread across by diffusion, or the fresh toiletries and other things that we have in our washroom, odonils. They're all in diffusion. Now in diffusion also we should ask, if I would have taken out the biryani from my refrigerator, would you smell biryani when you come to my house? No. That means, ye likh lijiye, diffusion is directly proportional to temperature. This is directly proportional. Now do you understand what is direct proportion? Hey, because direct proportion you have studied in grade 8. इसका मतलब क्या हुआ? अगर आप टेम्परेचर बढ़ाएंगे डिफ्यूजन बढ़ेगा. तो डिफ्यूजन को क्या बोलते हैं? रेट ऑफ डिफ्यूजन. डिफ्यूजन की स्पीड बढ़ जाएगी. इफ यू टेक आउट अ हॉट बिरयानी, इट्स स्मेल विल spread across much more faster than a biryani which is kept at a lower temperature. Diffusion. Again, one more question. Let's talk about some more examples of diffusion. Let's take water in one beaker and take your fountain pen and just press and put one drop of water into the fountain pen, into the beaker. What do you observe? The beaker's color starts, watercolors now starts occupying the color of the ink. What is happening? Ink is undergoing diffusion in water. क्या ये process fast होता है? देखो, सोचो, science is not about just mugging up. You take a beaker of water and in that beaker of water, take your fountain pen and just clear one drop of ink into the water. I hope every one of you must have done that once. Do you think, what is going to happen once you do that? What is going to happen? Participate. The color of the water changes and it tries to take the color of the ink. Will this process be fast or slow? No. Will this process be fast or slow? टैंग पीते हो? टैंग कैसे बनाते हैं? We take one glass of water और उसमें टैंग डाल देते हैं, कलरेशन आ जाता है ऑरेंज. स्लो है कि फास्ट है? फास्ट है. इससे ये पता चलता है लिक्विड्स की डिफ्यूजन रेट, दैट इंक विल चेंज इट्स कलर वेरी क्विकली. ब्लड का अगर एक ड्रॉप हम गिरा देंगे ना, immediately it will become red. Liquid diffusion rate is very fast. Liquid. If you take sugar and you drop it in water, you don't expect the sugar to immediately mix. However, if you take ink, all of you must have done, if you have the slightest interest of cake baking, then you must be using those food colors. When you put food color on milk, immediately the milk's color will change. That is how we change the color. That is very fast. Liquid diffusion is very fast. We are not talking about temperature out here. But out that, if you compare gases diffusion, liquid in liquid is faster or gas in gas is faster? Gas in gas will be faster. And how you should not, you don't answer it from your intuition. Diffusion means those particles have to go and occupy some space. Look at gas. Gas is a very friendly guy. आओ हमारे बस में आओ, बहुत सीट है. Gas particles are all spread across. गैस में आप जो भी चीज डालोगे ना, वो आराम से जाके छुप जाएगा. नाउ माय नेक्स्ट क्वेश्चन. पॉन्ड में मछलियां होती हैं. Fishes are there in ponds and rivers. Do fishes need oxygen to breathe? Yes. That means oxygen is a gas. Where is oxygen? In the atmosphere. Do we have marine plants in ponds? Yes. Plants need carbon dioxide. Where is carbon dioxide? In the atmosphere. Those carbon dioxide and oxygen must be dissolving into water. That is also gas getting dissolved in liquid. गैस के अंदर लिक्विड घुस जाता है, उसकी स्पेस बहुत ज्यादा है ना. So the other day when I concluded my class, I told you that do you expect solid in solid diffusion? Solid in solid is a very, very slow process. If I gave the example of chalk and a blackboard. If you have a very old blackboard and you've been writing on it with chalk for say decades and decades, you will see some marks of chalk which has gone inside the blackboard. You don't feel it with the scratch of your nail. Neither does it come off when you actually use a duster. That is called a solid in solid diffusion. Very slow process. In fact, if you keep two solids together for say 10-20 years, you will see little bit of discoloration on this coloration going on there. That's called solid in solid diffusion.
How can gas be diffused in water?
Gas takes in liquid things into it. Gas particles are much more.
How gas can be dissolved?
Gas is dissolved in water. Otherwise, how are plants and all alive? That's what you study as BOD, biological oxygen demand and chemical oxygen demand. Gases are molecules which are gas particles are spread huge amount of spaces between them. And the liquid has to go inside it. Push it.
Liquid में कैसे?
Air pressure से जा रहा है. Atmospheric pressure is more. So the oxygen is getting dissolved. क्यों नहीं डिसॉल्व होगा? आप डिओ स्प्रे जो यूज करते हैं उसमें क्या है? लिक्विड है, उसमें गैस है, प्रेशराइज्ड है. That's why how do you use the deo spray? You press the deo spray and the entire thing comes out. What is the deo spray's constituent? A deo spray has got a pressurized liquid that has nothing to do with aroma, nothing to do with aroma. It's a high pressure liquid, a gas which has been pressurized and converted into liquid form. Understand what is a deo spray? A deo spray has a gas which, if pressurized, turns into liquid. That liquid is inside your can. That has no aroma. That is the base component. Now what we will inject? We will inject our aroma component into it. Now the pressurized container has what? It has aroma, for which you are paying the price, and it also has the pressurized gas. Somebody has to carry the aroma, na? So when you actually press it, what are you doing? You have actually opened the door. What is the pressure outside? Atmospheric pressure. What is the pressure inside? Very high pressure. So where will the gas go? High pressure to low pressure. जैसे ही वो atmospheric pressure में आता है, it immediately becomes gas. दबाने से लिक्विड है. जैसे आप नोजल खोल देते हो, आपने छोड़ दिया ना उसको, वो गैस बन जाता है. एंड वी वांट इट टू बी गैस. तभी तो वो मेरे सारे बॉडी में स्प्रेड करेगा. वहां भी तो लिक्विड मिक्स हो रहा है, गैस लिक्विड में मिक्स हो रहा है. Atmospheric pressure is sufficient for atmospheric oxygen and carbon dioxide. Carbon dioxide is always a heavier gas. Carbon dioxide never goes up. Oxygen is there. The atmospheric pressure is sufficient to make them dissolve in water. अगर dissolve नहीं करोगे तो फिर प्राणी बचेंगे कैसे? Fishes and all won't be alive. Therefore, in cold, when you actually have freezing, freezing only happens on the top layer. पूरा freeze हो जाएगा तो अंदर सब मर गए ना. Don't think that in the Arctics and all, the entire water is frozen. No, the freezing happens only to a certain thickness and thereby maintaining the temperature. So have you understood particles of matter? What do you call? So we have cleared with, they are in motion, they are very small, and they also have spaces in between them. Okay. So in diffusion, please remember, diffusion is directly dependent on temperature. Some examples of diffusions are burning of incense stick, cooking, aroma related to cooking. That's also with diffusion. Any other example? Ink. When you are spilling ink in water, the water changing its color is also diffusion. Rate of diffusion means which diffusion happens faster. In liquids, the diffusion will happen faster because liquid and liquid, they have a lot of spaces. But if I compare gas and liquid, or say gas and gas, gases diffusion will be much more faster. Gas के पास space ही space है. Gas is like सृष्टि. हाँ आप बैठ सकते हो. आपके पास जगह, हाँ जगह है. सब बैठेंगे, सबको बिठाएगा. And solid is like our अभिक. नहीं सर बस फुल हो गया. No space. ठीक है? समझ में आया? Now particles of matter attract each other. ये बड़ा important है. How do we understand particles of matter attract each other? They say that, you know, your book says take a piece of chalk and hammer it, it breaks down into small, what do you call, fragments. Take a piece of iron and you hammer it, it doesn't break. Both are matter. With the same amount of force, I could shatter the chalk. I could not break the iron, which shows that particles of matter in iron must be attracting each other. नहीं जाने नहीं देंगे. बाहर से हैमर मार रहा है, मारने दो. हम तुम्हें नहीं छोड़ेंगे. Is there air around me? Yes. Can I put my hands into the air around me? Yes. So particles of air or gas do not hold each other strongly. Otherwise, my hand should not have gone. Now imagine I'm in a swimming pool. Can I put my hand inside the water? Yes. Can I put it so easily as I was doing it in the air? No. That means particles of liquid do attract each other. More than that. And imagine me now trying to swim on ice block. Can I put my hand inside? No. So particles of solid attract each other very strongly. Have you understood this thing? Okay. Can I go ahead to the, anyone has any query out here? So we actually covered a little bit of proof on all these four statements. Is this understood? Anyone has any query? One more aspect that you need to study at this grade on this, in this level, is you need to have an idea about rigid, the concept of rigid and fluid. यहाँ बहुत सारा interesting चीजें मिलेंगी अभी. Rigid. What is rigid? that person has a very rigid nature. His decisions he never changes. Rigid matlab, sir, my mom will come and meet you. Yes. So what? My decision still remains the same. No matter how much pressure you put on me, my decision doesn't change. So what do you call me? Hitler. Hitler. So in chemistry, you can't call me Hitler. What will you call me? Rigid. अगर आपको rigid का right definition चाहिए ना, right definition, like rigid is something that usually does not bend. But that's not if you want to understand it from science, rigid is like this. Try to understand. This is, say, a piece of substance, right? This is a piece of substance. And I am marking two arbitrary points between here. Say this is a point A and this is a point B. Understood? Between A and B, I measure what is the distance. Say the distance is some X centimeters or X meters. Let's say X millimeters is the distance between A and B. Have you understood? Rigid का मतलब क्या है? Rigid का मतलब है now if I bring say external forces, मैंने यहां से एक external force दिया, यहां से एक force दिया, यहां से एक force दिया, यहां से एक force, जैसे बोलता है ना, आप मुझे जितना भी मारिए मूवीज में नहीं बताएगा साहब, तो क्या बोलते हैं? He is very rigid. सच नहीं बोल रहा है. When somebody tortures somebody to get the, so if you apply forces, you still find that the distance between the 2 points is still x mm. That means these 2 points did not succumb to this external pressure. Succumb करने से क्या होगा? ये 2 point या तो पास आ सकते हैं, distort हो सकते हैं, ऐसे जा सकते हैं. In either case we say, where was your rigidity? तुमको 2 थप्पड़ मारते तुम्हारा बैंड, बताता हूं. That means you are not rigid. You are flexible. Tomorrow submit your homework. You didn't come. Your mother comes or parent comes. No, I actually didn't mean tomorrow, like the schools nowadays please the parents. I actually said that the child can submit any day. And then parent goes and says, Dekho, your teacher became and told me like this. So teacher was not rigid. Back in our days, 3 Idiot में बोलता है ना, प्राइम मिनिस्टर का बेटा भी होते तो भी कॉपी सबमिट नहीं लूंगा. Rigid. Did you understand? And if I remove these forces, then also I find that there is no change. This is the exact definition of rigid. Let's take a sofa cushion. If you apply force on a sofa cushion, 2 points on the cushion, do they become closer to each other? Yes. Or they may become far away from each other depending on what type of forces you are applying. And if you release the forces, the points again come back to their original position. Is spring rigid? Spring देख लो, spring rigid होता है? नहीं, spring को खींचा तो लंबा हुआ, छोड़ दो तो वही है. इसमें कुछ ऐसे भी, कैसे हैं आप? How are you? How are things? If you don't ask me, I'm good. If you ask me, I have lots to share. और rigid नहीं है ये. Next question is there anything which is rigid in this universe? Perfectly rigid कोई चीज नहीं है. Do we have anything that is a perfectly rigid? No. ये आपका बुक नहीं बताएगा, आप लिख लीजिए. There is nothing which is a perfectly rigid. ऐसा कोई substance है ही नहीं. There is nothing. Now you may say, what about iron? Even in iron there is compression. वरना गाड़ी जब धक्का खाता है हेड ऑन कोलिशन में, फिर एयरबैग्स की क्या जरूरत है? गाड़ी चेपटा ही नहीं होना चाहिए. Nothing is perfectly rigid. What you feel rigid is everything which is, we say, close to rigid. But when you go to grade 11 and 12, when you study physics, they will teach you everything like Newton's laws and all. A rigid body. Good boy. Have you seen a good boy? Good girl. Okay, very nice. Good girl. Hannah, have you seen a good girl? Hannah will say, actually, I wanted to say, I am only the good girl, sir. How can you say that? Have you seen a good? There is nothing called a perfectly good girl. There's nothing called. All we see is the closest to rigid. So when we define everything, the school's code of conduct, like the girls will do this, girl will do this, keeping in mind an assumed arbitrary, perfectly good girl. ऐसा कोई होता नहीं है. Perfect कोई चीज नहीं है. There's nothing called perfect rigid. Plywood दबा सकते हो, कहाँ rigid है? Irons also bend, they're not rigid. Rigid means no matter how much force you give these two terms. Okay, so there is something called rigid. Rigid is something that does not bend. Or we say is not flexible. Anybody would like to take a dive at what is a fluid? Fluid is anything that flows. Anything that flows. Like a liquid cow dung. हाँ क्या है खराब थोड़ी है एग्जाम्पल है गंदे एग्जाम्पल्स याद रहते हैं फ्रेश cow dung is also fluid. If the road was like this, the cow dung would have, है ना? Fluid. Fluid is something that flows. So we can say gases can be fluid as well as liquid can also be fluid. Hey, you all have studied all these things in friction. Friction caused by fluid is known as drag. And drags are taken care by streamlining. What, sir? Those were in grade 8. So what? You have to understand that also. अच्छा फिर एक बात बोलते हैं. If this is the case, a little bit of English. Okay. Can you tell me the difference between anyone? This is English class. This is nothing to do with chemistry. Can you distinguish between these two words? Fragile is anything that can be easily broken. So in airports, we see a lot of things with a fragile sticker and a glass, a wine glass shown on it. Okay, understood. Aage. Metal can be broken into fine, smaller pieces, like my skull. What is hard? ये क्या है? हाँ, wood है. ये क्या है? Yes. Hey, in online also you have to participate. See, otherwise you can't expect me to go on talking. That's very harsh on my part. How can one person go on talking? What is wood? How do you classify wood here? ये तो इंग्लिश की बातें हो रही है, नहीं तो केमिस्ट्री कौन सी बात है? हाँ? Soft. Hey, bring that cricket bat. I'll bang his head with that cricket bat. Let us understand whether the wood is soft or hard. ये क्या है? फ्रेजाइल ना, टूटते ही गिर गया. बचपन में थे तो मम्मा हमें हमेशा प्लास्टिक के ग्लास में पीने देता था. How many of you, when you go to any of your family friends' house, at this age also you are served in that IKEA plastic glass? The host is not comfortable to give a glass crockery in your hand. Don't feel ashamed. You can still raise your hand. नहीं वो पी नहीं सकता है. Butterfingers गिरा देता है. Anyone? जिसके घर में जाते हैं वो आपको कांच देता है. वाओ, देसो कांच नहीं, वो प्लास्टिक होगा. फिर कांच महंगा होता है. अरे बताइए कांच क्या है? कांच फ्रेजाइल है. वेरी गुड. और कांच ब्रिटल भी है. मैं कुछ और बोलूंगा. मैं तो बोलूंगा ग्लास हार्ड है. एंड आई एम 100% करेक्ट. हार्ड. हार्ड का मतलब, और जो वुड है ना, ये है सॉफ्ट. एक एग्जांपल ले लो. टेक ए पीस ऑफ ग्लास एंड टेक योर फेवरेट क्रिकेट बैट एंड रन द ग्लास ऑन योर क्रिकेट बैट. हु रिसीव्स द स्क्रैच? Who receives the scratch? The cricket bat. That's softer. Do you know the principle of cutting? Cutting. A hard substance can cut a soft substance. When you use a knife on a potato, the potato is soft. That's why you are able to cut the potato or peel the potato with knife. If you take the same knife and you try to cut my window grills, you will see that the knife is getting eroded out. That means the grill is much more harder. But to cut a grill, you will see they don't use big knife. They use a very thin hacksaw blade. Have you seen a hacksaw blade? The hacksaw blade's teeth are very, very hard. Hacksaw blade, अगर आपके हाथ में ऐसा ऐसा किया ना, giving you anesthesia, they can with a smooth cut take your bone away. अच्छा, how many of you girls have sometimes faced that you've gone to a jeweler and you have a ring, बचपन में किसी बुआ या मामी ने दिया होगा, and that ring has become so tight that it cannot come out? How do we take out ring? Soap water डालते नहीं, अब इसको काटना पड़ेगा. जब जाती हुई सब देखो, there will be one auntie or somebody who will come with one ring or one churi. They will use a blade which has a thread like blade, एकदम thread, और उससे चेंचे 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 4 बार मारेगा, रिंग कट गया. So it is not about bulky. Wood is very soft. That's why we are able to, when hammer nails inside wood. Can you take your compass? Can you penetrate compass through glass? No. Glass is very, very hard. That's why if you fall on glass, जो दिखाते हैं ना हिंदी मूवीज में, बोतल मार देने से माथा फट जाता है, ऐसा क्यों? बोतल तो फट गया, because glass is brittle. Brittle and fragile means you cannot resist shock. Wood can resist shock. Shock means sudden load. If I bang a glass bottle on your head, the glass bottle will break, but you will get at least 7 stitches on your head. आपका सर भी फटेगा 2 टुकड़ा में. Ice, hardest substance known to man after diamond. Take a ice cube, put it in a catapult and hit on somebody's head. गया वो, gone forever. Ice is very, very hard. इसलिए बर्फ में गिरने से फ्रैक्चर होगा ही होगा आपका. Wood is soft. Wood is not hard. नहीं तो वुड के तलवार बनते थे, नहीं बनते है ना. ग्लास इज वेरी हार्ड. ग्लास इज ब्रिटल. वी कांट टेक अ कॉम्पास एंड पेनिट्रेट इनसाइड ग्लास. ग्लास इज वेरी, very hard. Even if you heat the compass also, you cannot put it inside. That if you are able to do, that is not glass, that is acrylic. Like you have these ones in Pebble City, in our apartment, apart from tower A and B, only tower A and B, the original windows are of glass. After that, every window that you have is actually acrylic. These windows are light. If you take heated compass and put it here, very heated, it will work. But in glass, it will not work. This is glass. No, this is not glass. This is fiber. Had it been glass, why? This is very costly. Glass hone se it will become very heavy. There will be a mark on your nose. This is not glass. These are fiber glasses. This is not glass. Okay? Understood this concept? Okay. So rigid, fluid. So what do we say about rigid and fluid? Fluids are the substance that flows. Gases and liquids are generally said to be fluid, whereas solids are said to be rigid. Now don't compare between semi-solid like paraffin and other things, but usually say a block of iron is taken to be rigid. Now what is the difference between rigid and gas and liquid? Say rigid means solid and fluid. What is the striking difference between them? ये portion मिटा देता हूँ. This was our discussion. Why do you think that you have been able to classify them as rigid and the other one as fluid? Rigid means it does not bend. That means what? The space between particles, yes, is very less. Whereas here the space is comparatively more. And here the space is maximum. Have we understood? Now we are in a position to take our discussion further and understand physical classification of matter. That is, we are ready to now get into plasma. We don't discuss only. Those are all unwanted. I don't know why they include that thing as a discussion. Plasma is ionized gas. Plasma I never learned up till my engineering. But nowadays children first will say 2 questions. So what is plasma and what is Bose-Einstein condensate? तुम बेटा यही पढ़ लो, ये काफी है. पहले काम की चीज पढ़ लें, उसके बाद प्लाज्मा. Plasma is another state of matter, they say. That's ionized gas. पहले प्लाज्मा टीवीज भी आते थे, फिर वो चले नहीं ज्यादा, लेस चला. Right? So we go into our next level of discussion where we will now take matter and we will try to classify matter physically, not chemically, physically. And the physical classification of matter will be under 3 heads, that is solid, liquid, and gas. But before we start this, one more interesting thing we should understand. We should know a little bit of something called the kinetic theory of matter. Okay, we should also understand something called the kinetic theory of matter. Be able to complete today. Okay, let's understand this theory. So what we have matter. Kinetic theory of matter will be haunting you in grade 9, grade 11 chemistry, grade 12 physics also. ये आपके पीछे चलता रहेगा. Kinetic means anything that is moving. Kinetic energy. Kinetic means anything that is moving. Kinetic theory of matter. What does it say? Very simple. For our grade 9 level, we'll take it very simple. Matter is composed of very small particles. Matter is composed of very small particles. So the first thing is, if you have matter, then matter is composed of very small particles. What you have studied so far, it also says the same. The second is, these particles will also have space between them. So nothing new for us. The third thing, it also says that the particles are always in motion. Yeah, in motion. That means there is a movement between the particles. There is a movement between the particles. And the particles being in motion, please understand, if the particles are in motion, that means these particles have some kinetic energy associated with them. Acha, what is kinetic energy? Let us understand first that. So we need to understand what is kinetic energy. Energy can neither be created nor be destroyed, but energy can be converted from one form to another. One of the form of energy is called kinetic energy, and it is the energy due to which a body is in motion. In other sense, just as a layman word, any moving body has kinetic energy with it. So if I ask you, an arrow which has been shot, it is going with what energy? Kinetic energy. A cricket ball which is moving up high up in the air, it is moving with kinetic energy. A football which is right now at my house and I'm not playing and it is stored in one corner, does it have kinetic energy? No. Kinetic energy is the energy associated with the body when it is in motion. If you are in motion, then only you have kinetic energy. And when you go to, even in this class in physics, you will learn kinetic energy's formula, लिख के रख लो अभी, physics में पढ़ेंगे, is given by half mv square, where m stands for mass and v stands for velocity. So you put your brains now, if a body is at rest, its velocity must be equal to 0. So kinetic energy becomes 0. A stationary body does not have kinetic energies. Now what does the kinetic theory of matter tell us? Kinetic theory of matter tells us that these particles are very small, they have spaces between them, and they are associated with kinetic energy. Sir, is it true for solids? Yes. Is it true for liquid? Yes. Is it true for gas? Yes. That means you mean to say, sir, that all the particles of all type of matters are having movement in them? 100% they have movement in them. But I don't see that a piece of Cadbury's Dairy Milk which has been kept on my table is moving. That's because the movement in case of solid is much, much less. But the movement, if I just bring a little bit of oxygen into this room and I release it, what happens to the oxygen? It just spreads across in the whole room. That shows that the movement of particles in case of gas is very, very high. And if you actually take liquid, यहाँ से आपको सारे आंसर्स मिलते जाएंगे. Take liquid, pour it in a cup. It takes the shape of cup. Pour it in bucket. It takes the shape of bucket. So there is movement in the case of liquid particles, but not as much as gas. Gases are like you guys, all you, and I'll say this for girls because I have a daughter also. Girls and their wardrobes. No matter you give them all 3 rooms, still they don't have space. They are short of space. How many of you open your wardrobes with your helmet wearing? I see that in my house. खोला नहीं, ड्राम से सब गिरना शुरू हो गया और उसी को मिलता है. If I go and search, I will not get anything. उसको मिल भी जाता है. Don't touch. I know where it is. So girls and gases are same. You give them the whole house. You give them the kitchen cabinets. वहां भी अपने socks box रख रहे हैं. Space is so less in this house. समझ में आ रहा है?
सर लेकिन
वॉल्यूम सेम रहेगा, वॉल्यूम सेम रहेगा। 1 लीटर मस्टर्ड ऑयल आप अपने बैग में डालने से बैग का शेप लेगा, आप उसको पाइप में डालेंगे पाइप का शेप, वो 2 लीटर नहीं हो सकता। ऐसा होता तो सारे मम्मियां खुश हो जाती, घर का खर्चा कम हो गया। तेल लाए हैं जी आप? हाँ हाँ मैं तेल लाया हूं बॉटल में, हाँ उसे हमारे बाथटब में रख दीजिए, पूरा बाथटब भर जाएगा, इस महीने के तेल पूड़ियां वहीं पे तलेंगे। ऐसा थोड़ी है, ऐसा होने से तो दुकान ही नहीं चलता। ब्लिंकिट विंकिट सब ऐसे रास्ते में बैठ के बैंगन बेचते रहते, है ना। आई वुड हैव लव्ड दैट इफ इट वाज विद आइसक्रीम। आइसक्रीम पिघला दो और आइसक्रीम बनता है, वाह। ये समझ में आया? काइनेटिक थ्योरी ऑफ मैटर। तो ये काइनेटिक थ्योरी ऑफ मैटर से हमें 3 चीज मिलता है। मैटर इज कंपोज्ड ऑफ वेरी स्मॉल पार्टिकल्स, घूम फिर के वही कहानी चल रहा है। पार्टिकल्स हैव गॉट स्पेस बिटवीन देम एंड पार्टिकल्स आर ऑलवेज इन मोशन। ये चीज क्लियर हो गया? ओके, नाउ with this concept let us try to understand solid liquid and gas के basic differentiation को समझने की कोशिश करते हैं। आइए, and this is one question which will come in all your unit tests and all your half yearlies, where चेपू question है मतलब। आइए, so we will see the difference between solid liquids and gases। छोटा छोटा करके लिखेंगे ताकि समझ में आता जाए। solid liquids and gases, okay, and the discussion that we had, this discussion, इससे एक और important point आएगा। Sorry, I had forgotten that, so let me add that point also। Okay, I've just made it small। If you want to answer every question from this chapter in a smart manner, then remember 3 fundas। 2 fundas. One is called IPFOA and one is IPD। Now what is IPFOA and IPD? इसके ऊपर आप सब आंसर कर सकते हैं। ये IP बाद में हो जाएगा क्या? इन हायर क्लासेस ये हो जाएगा IMFOA and IMD। This stands for interparticle force of attraction। Interparticle force of attraction, and this stands for interparticle distance। इंटर स्कूल टूर्नामेंट, इंटर स्कूल टूर्नामेंट मतलब स्कूलों के बीच का टूर्नामेंट। इंटर पार्टिकल फोर्स ऑफ अट्रैक्शन, पहले इसको समझते हैं। particle, this is called a particle P1 and this is a particle P2। whether you are a solid, whether you are a liquid or whether you are a gas, kinetic theory of matter told you what, that the particles are very small, particles have got spaces between them। ये स्पेस को कौन कंट्रोल करता है? ये स्पेस, जैसे कहते हैं ना हमारे उस रिश्तेदार के साथ ज्यादा बातचीत नहीं है, so by literature do we maintain a distance with them? Yes, we maintain a distance। why? We don't have any force of attraction। do you get it? So if 2 particles have a force of attraction between them, then this is called interparticle force of attraction, and this part is known as the interparticle distance। try to understand children, थोड़ा सा इंटरेस्ट दो। अगर फोर्स ऑफ अट्रैक्शन ज्यादा होगा तो डिस्टेंस कैसा होगा? कम होगा। आपको क्या लगता है सॉलिड्स में फोर्स ऑफ अट्रैक्शन कम है या ज्यादा है? सॉलिड्स में, सुनिए बात को, सॉलिड्स में फोर्स ऑफ अट्रैक्शन स्ट्रांग है। अरे सॉलिड के अंदर मैं हाथ घुसा सकता हूं? नो, व्हाई? बिकॉज द पार्टिकल्स ऑफ सॉलिड आर क्लोजली पैक्ड। कौन पैक किया? आपने कोई टेप मार के पैक किया है क्या? नो, दिस इज बिकॉज ऑफ दिस फोर्स ऑफ अट्रैक्शन। solids have got the highest force of attraction, so what about the space between them? Less, and that's the reason if I pour water on this table, the water does not get inside the table, water को entry नहीं मिल रहा है, particles इतने आसपास है। my best friend will always sit beside me in the bus। अब उसके बीच में तुम लैब का पपी घुसाओगे तो घुसेगा? सिर्फ मच्छर घुस सकते हैं। क्यों? मच्छर इज इवन मोर टाइनी। समझ में आ रहा है कि नहीं? If the particle, now let's look at liquid. Liquids, can I put my hand through liquid? Yes. So what do you comment on the interparticle force of attraction in liquid? comparatively less as compared to solids. Now you're getting it. So if the particles force of attraction is this, liquid के particle थोड़े दूर दूर है, अब बीच में चीनी के पार्टिकल आ गए सब, because the distance is more. और गैस क्या है? गैस आर लाइक द चिल्ड्रन ऑफ आवर अपार्टमेंट, एनी टाइम दे आर प्लेइंग आउटसाइड. अभी जाओ रेड मारो हमारे सोसाइटी में, मच्छर से ज्यादा बच्चे हैं बाहर, सब जहां इच्छा भाग रहे हैं. देयर इज नो इंटर पार्टिकल फोर्स ऑफ अट्रैक्शन. मदर चाइल्ड भी अट्रैक्शन नहीं है, सब सब क्या वो खेल रहे हैं, बच्चे बाहर है ना, दे प्लेइंग आउटसाइड. तो स्पेस तो आ गया. क्या स्पेस घुसा उसमें? बहुत स्पेस. यहां बच्चों ने गाली गलौज सीखा. आई लर्न 2 more abusive words today while playing outside with my friends. ऐसा घुस रहे हैं. समझ में आ रहा है? यह हंस रहा है, सोच रहा है मेरी बात बोल रहा है सर, बिल्कुल है. इज इट क्लियर? ये जो कहानी अभी हम लिखने वाले हैं ना, ये 2 पॉइंट याद रखिए लाइफ भर. इंटर पार्टिकल फोर्स ऑफ अट्रैक्शन. एंड व्हाई डिड आई राइट IMF? Because when you go higher, particle word will be changed by molecule. Intermolecular force of attraction, ये आपके साथ, it will be attached to your studies till grade 12 engineering first year second year तक, or if you are going in medical also आपके रहा. Intermolecular force of attraction. If the intermolecular force of attraction is stronger, then I will expect more definite shape. Just think, ice cream batter when it was not frozen, do they have force of attraction? No, that's why it's not having a shape. सारा रात जब हमने ठंडा कर दिया तो क्या हो गया? आइसक्रीम का बैटर कंडेंस होते 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 शेप आ गया उसमें. तो यहां एक और बात आता है, that if I start heating this, अगर आप इसको हीट करते हो, what is heat? Heat is a form of energy, and this energy you are applying toward these particles. Particles were already in motion, थोड़ा थोड़ा. तो ये एनर्जी क्या? एनर्जी कैन neither be created nor be destroyed. This energy, yes, this energy now gets transformed into what? Kinetic energy. You want to understand it properly? 2 kids who never study, their father while coming from airport brings more Hamleys toy, और kinetic energy दे रहा है. अब बच्चे और भाग रहे हैं ऐसे. So when you give heat, don't you expect the sugar? Suppose sugar was no more mixing in water. I started heating it. So what did I do? I gave more kinetic energy to the water particles. It's just like that indigo person in the airport who would say, get inside. जैसे जोर से बोलता है ना, सब लोग अंदर चला जाता है, और भी आदमी बस के अंदर आ जाते हैं. Common sense. So the more energy that you give, the energy gets converted into kinetic energy. So this whole story will be between interparticle force of attraction, interparticle distance, and heat, जिसको आप पढ़ेंगे temperature. Temperature is a measure of the content of heat. Now just see the ulta. I made ice cream batter. After making ice cream, do we put it in an oven or do we put it in a refrigerator? Refrigerator. So what I'm doing, I'm withdrawing heat. I'm withdrawing their kinetic energy. I'm being that parent. No more toys for you. पापा मैं कल से ही पढ़ूंगा, मैं आज से बाहर नहीं जाऊंगा, मैं सारा दिन पढ़ाई लिखाई करूंगा. They come more closer, and as a result, the distance reduces. That's the example I told, that if you make ORS or electrol water in a bottle, electrol पूरा dissolve हो जाता है. Take that bottle and put it in refrigerator. 20 minutes. You will see the entire electrol has come out. Why? The people who had separated now say, sit, come sit. तुम मार जाओ. Water and water come close together. Electrol को क्या बोलता है? बाहर निकलो. Electrol starts going out. See, these things you should actually try. A pack of electrol is hardly costly. If I am at your place, to love science, I will do that. एक ORS ले लो, कितना है? 13 rupees. बना के पी लेना ना, क्या जाता है उसमें. लेकिन उसमें देखो, when you are putting electrol in normal water, the electrol will immediately dissolve. What did sir say? Sir said to put that bottle back in fridge. करके देखो, सबके घर में ORS का एक ना एक पैकेट रहेगा. जैसे आप फ्रिज में रख दोगे ना, ज्यादा नहीं, 10 minutes, and you did not put it in refrigerator, means deep freeze. You just put it in the normal fridge compartment and watch some IPL 3-4 overs. फिर जाके देखो, व्हाइट कलर का पूरा सॉल्ट बाहर आ जाएगा. क्यों? क्योंकि पानी उसको रिजेक्ट. ये कहानी समझ में आया? या प्लीज.
हम फ्रीजर में डालते हैं तो काइनेटिक एनर्जी
काइनेटिक एनर्जी कम होना क्योंकि आप हीट विड्रॉ करा रहे हो ना उनसे, यू आर विड्रॉइंग हीट फ्रॉम इट. If you withdraw heat, energy has to come out. Energy gets converted. What energy was within them? Kinetic energy. They have to give away heat now. They are giving that heat in the form of पैसा अपने पास. हम लोग अमेरिका में रहते हैं. अभी जैसे उसको ले लो, our new friend from Dubai. If she goes to school and market tomorrow, what currency she has? AED. We want money back from her, so she will withdraw AED. We will take out INR. Ultimately, her reserves will go down. So kinetic energy is withdrawn in the form of heat. Heat in physics. Achha, I hope in physics there is nothing called cold. An ice cream is less hot than iron. Everything is heat in physics. So if you withdraw heat, you are actually withdrawing heat. You are cooling it. तो cool करने से kinetic है. ये story से अभी यहाँ पूरा clear हो जाएगा. Solids में कैसा रहता है? Solids में we are going to have definite shape and definite volume. Do you agree or not? Your beautiful face has got a definite shape and your head has a definite volume. What about liquid? Liquid में क्या लिखोगे? Definite volume. Yeah, definite volume, but no definite shape. Why no definite shape? Liquids take the shape of the container. Children will need 5 minutes. I need to complete this and then only I'll release you. Children, liquids will take the shape of the container in which they are placed. Now my question arises, why? Because in liquid, the interparticular force of attraction is less. सारा चीज इसी से आंसर हो जाएगा. ये तीन, IFOA, IPFOA, IPD and kinetic energy. So here we have less kinetic energy, more force of attraction, less distance. Therefore compact. Here we have a little bit more kinetic energy and less force of attraction as compared to this, but still not. बच्चे फिर भी कंट्रोल में हैं. रात को घर में आ जाते हैं, शाम तक बाहर घूमते रहते हैं. टिपिकल पेबल चिल्ड्रन. By 10 o'clock they will come home. It's not that they will not come home. They'll come home by 10 o'clock. इसमें क्या है? No definite volume and no definite shape. नहीं होता है ना, कैसे होगा? मैंने इस रूम में कुछ अगरबत्ती के स्मेल गैस के रूप में छोड़े, आप जाके वहां पकड़ोगे, गैस उधर है, उधर है क्या? पूरे घर में फैल गया. पॉइंट नंबर 1 क्लियर. हालांकि अलग कलर से लिखना चाहिए था, बट एक्चुअली नेक्स्ट, सॉलिड्स कैनॉट बी कंप्रेस्ड मच. कंप्रेस का मतलब समझते हैं? कंप्रेस मतलब दबा देना, कंप्रेस मतलब वॉल्यूम कम करना. Why solids cannot be compressed much? You can still compress them. Wood को थोड़ा सा compress कर सकते हैं. Solids cannot be compressed because in solids interparticular force of attraction is very high. There is no space. और कितना compress करोगे? Compress करने के लिए space तो चाहिए. Already it's like थोड़ा अंदर बैठो ना, और कितना अंदर बैठो? सटक के उसके गोद में बैठ जाऊं क्या? Already सटक के बैठे हैं, और कितना अंदर बैठे हैं? Liquids में क्या लिखेंगे? Liquids can be slightly compressed, not more. You want to see its proof? Buy one 3 rupees 4 rupees लेगा, syringe मिलेगा मैक प्लस में. Take a syringe, fill it with water. syringe के हेड में नीडल मत लगाओ, उंगली डाल के बंद कर दो और syringe को बंद करने की कोशिश करो. syringe press नहीं होगा. That shows that water cannot be compressed, but liquids can slightly, because in liquid what happens? Interparticular force of attraction is little less, some space is there. And gas में क्या होता है? Highly compressible. Highly compressible. Wow. Why? Because they are our LPG, liquefied petroleum gas. Delhi में CNG, compressed natural gas. You have compressed the gas. Gas को हम compress कर सकते हैं. Cigarette lighters and all that liquid that you see is all compressed gas. Solids have high density. Okay, density. Yes. Aditi, quickly, one quick question and quick answer. What is heavy? 1 kg iron or 1 kg cotton?
I think both the same.
Both are same. What is difference is 1 kg iron I can pilfer in my pocket, but 1 kg cotton I have to come like Santa Claus. What is more? Volume is more. That is because of density. Anything which is more dense is compact in shape. I expect the solids to be more dense because the interparticular force of attraction is very high, the distance is less, they are closely packed. सारा कहानी इसी से आंसर होता रहता है, देखो सब कुछ है. So in solids have high density, liquids have comparatively less, and these have least density. इनका कोई density है ही नहीं. In fact, majority of the gases are so less dense, they are all lighter than air. That's why नीचे से वाटर को ऊपर उठाने के लिए हमारे अपार्टमेंट में पंप है, बट जो हम खाना पकाने का गैस है ना, we don't have a pump. We have the cylinders right at the basement and they are just turned on and they are climbing up till 19 floors. You don't have a pump for that because they are lighter. इसीलिए बलून ऊपर जाता है. Density is the ratio of mass upon volume. Mass upon volume. Density को हम ऐसे लिखते हैं, density, ये देखो ना, density is equal to mass upon volume. Now just see, if you increase the denominator, the quotient should fall ना. Volume बढ़ेगा like the cotton, density गिर जाएगा. Volume कम करेंगे like the iron, density बढ़ जाएगा. Then second is solid does not flow. Sir, I saw butter. अरे बटर फ्लो नहीं किया था, बटर लिक्विड फॉर्म में फ्लो किया था. सॉलिड डज नॉट फ्लो. लिक्विड्स आर फ्लूइडिक, and gases, the fluidity is the highest. Right. I missed out any point. थोड़ा ready होइए. Grade 9, don't expect the class to end exactly at 1 hour. You may curse me or you can do whatever you want. But I missed one point. Gases, sorry, not gases, solids. Don't fill their container. Don't fill their container fully. What I mean to say that, take a box and in that box put one new soap cake. Do you expect the whole box to be filled up? No. Liquids fill partially. This was Ananya's question. अगर हम मस्टर्ड ऑयल 1 लीटर लाएंगे अनन्या, तो ओनली 1 लीटर वर्थ ही फिल करेगा. ऐसा नहीं कि पूरा बाथटब में मस्टर्ड ऑयल हो जाएगा, फिर तो घर में तेल ही तेल. और इसमें क्या है, फिल completely. Okay, completely. Now let us again debate this question. Why do solids not fill their containers completely? Because in solids the interparticle force of attraction is highest. Particles are held each other. Container is like the entire pebble city and solid particles are like the children. In solids the parent is very strong. Mama, I want to go and play basketball now. No, stay inside. बड़ा रहता है. लिक्विड में कैसा रहता है, जाने भी दीजिए ना, अभी तो वेकेशंस चल रहे हैं ना बच्चों की, उन्हें खेलने दे दीजिए, कोई बात नहीं, बच्चा खेल रहा है. और यहाँ क्या है, आई एम नॉट अ पेरेंट हु माइक्रो मैनेजेस. आई लव द किड्स टू हैव देयर ओन फ्रीडम, देयर थॉट प्रोसेस. तो ये थॉट प्रोसेस करते करते बच्चा सारा दिन बाहर घूम रहा है. ये वो देखो, तुम्हारे जिंदगी के साथ ही सारे एग्जाम्पल है. नेक्स्ट वाला देखो, सॉलिड्स डू नॉट फ्लो. क्यों फ्लो नहीं करता है? मम्मा, आई वांट टू गो टू रत्नदीप. स्टॉप. इंटरपार्टिकल फोर्स, हाँ जाने दीजिए ना. मम्मा, मुझे तो कुछ खरीदना ही नहीं है, संजना जा रही है, मैं भी जाना चाहती हूँ. हाँ बेटा, तुम संजना क्यों, सबके साथ जाते रहो. समझ में आया? हाई डेंसिटी, क्लोज पैकिंग. द फैमिली दैट ईट्स एंड डाइन्स टुगेदर, चिल्ड्रन ऑफ दैट फैमिली डू गुड. हाई डेंसिटी. यहाँ बच्चे तो अलग डोर से घुसते हैं, उनका डोर अलग है, मेरा डोर अलग. यहाँ बच्चे तो अरे वो लोग तो चले गए, पता नहीं कुछ समर कैंप में गए हैं. इंटरपार्टिकुलर फोर्स ऑफ अट्रैक्शन कैनॉट बी कंप्रेस्ड. आप इन्हें गाली वाली खराब बातें सिखा ही नहीं सकते हो, क्योंकि इनके बीच में स्पेस ही नहीं है. दे आर ओनली फिल्ड विद एजुकेशन 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 एजुकेशन. इनमें क्या है, थोड़ा एजुकेशन, थोड़ा नेटफ्लिक्स. इन्होंने कभी किताब खरीदी ही नहीं, इनके पास सब सब्सक्रिप्शन है. समझ में आ गया? ये डेफिनेट शेप एंड वॉल्यूम. अब आप तुम यूनिट टेस्ट में मिस्टेक कर ही नहीं सकते हो. Definite shape and volume, why? Because the particles are held together. इसमें definite volume but not definite shape. थोड़ा सा I think this is the best. ज्यादा स्ट्रिक्ट होने से भी लाइफ में अच्छा नहीं है, ज्यादा छोड़ देना भी अच्छा नहीं है, ये रहना चाहिए. और इनका कैसा रहता है? इनका रहता है सॉलिड लिक्विड गैस. समझ में आया? I now want you, after these class notes are done, to study everything till the first question answer section of Lakshmi Singh, the first question answer. So wait, you can spend 2 minutes more with me. That means everything that you have studied, you will study, and then on a fine day you will take your pen and you take the Lakshmi Singh book and you first see the MCQs and try to tick the MCQs. If you are scoring more than 90-95, आपके दिमाग में जो मैंने पढ़ाया वो घुसा है. उससे कम है तो दोबारा पढ़िए. Then make your notes. Then try to answer the VSAQs, VSAQs, very short answer. SAQ, short answer. Long answers भी देखिए and HOTS को भी देखिए. It is not only about answering. Don't think like grade 8. Ma'am has given this worksheet and questions will come from this worksheet. ऐसा नहीं है. Have you understood? And take time to go to a website called cbsc.nic.in. In there, select the link which says academic website. There, go and select curriculum 25-26. That is your curriculum. Secondary school means 9 and 10 syllabus will be together. Nothing can be asked in your school which is outside that syllabus. CBSE academic website. मैं चाहूँ तो मैं भी दिखा सकता हूँ. I will upload it for you, but you try to go and see what will I be. You may be from any school in India or abroad, but ultimately your exam will be as per the CBSE curriculum. उसके बाहर से कुछ नहीं आ सकता है. समझ में आया? Clear? So please study and come. What you are studying are very simple, easy to understand and easy to forget. So my mantra says interparticle distance and the story of kinetic energy. Next we will go into temperature. We'll study temperature in our